Okay, so we were in the middle of this problem. I was showing you the second method of calculating the pOH. So we just found the hydroxide ion concentration. So now we're going to use pOH is equal to negative log of the OH. So this will be our second formula. And you can work this out with either method. I'm just showing you both ways to do it. One thing I wanted to do was make sure we were able to use this formula to show you how you would actually plug into it. So we just found the OH, so we're going to plug into this formula. So pOH is equal to negative log of 2.9 times 10 to the negative 9. So you're going to plug in negative log 2.9 times 10 to the negative 9. And since this has 2 sig figs, we're going to round our answer to 2 sig figs. So pOH, plug that in. Get 8.5 for the pOH. Now I want you to notice either way we got the same exact answer. So either method works. It just kind of depends on which way you think of first. All right, let's look at number 7. Number 7 says the pH is 6. What's the hydronium ion concentration? Well, remember, class, hydronium ion is the same thing as the hydrogen ion. So they're just asking us to find the H plus concentration. So we have a formula that has both of these symbols in it. pH equals negative log of hydrogen. So we're going to plug in for what we were given. So here we're given the pH. So be careful, y'all. Make sure you plug it into the right place. The pH is 6 equals negative log of H plus. All right. Now we have to isolate our variable, which is X here or H plus. So the first thing you've got to do, class, is to move that negative sign over. So we're going to divide both sides by negative 1, which is going to make this side positive and this side negative. Now we can move the log over. Now, the opposite of log is antilog. So if you look on your calculator, your log base 10 button here, right above it is 10 to the x. Well, that's antilog. So to access that, we're going to hit second log. All right, and we get ready for that. But on your paper, to show your work, you're going to say 10 to the x, or the inverse log, 10 to the x. So the way you're going to plug this in is you're going to hit second log of a negative 6. Remember, class, for these problems here, you're going to always be taking the antilog of a negative number. You have to always remember to divide by a negative 1. So you're going to say second log, and when you hit second log, you get a 10 to a little carrot top that pops up. And now you're going to plug in negative 6. Enter. And so you see we get 1 times 10 to the negative 6. And so your answer needs to be rounded to 1 sig fig. And keep in mind what we've done is we've isolated our variable, which is H plus. So what we're solving for is H plus, the hydrogen ion concentration, is going to be 1 times 10 to the negative 6. And since we're solving for a bracketed ion, it should have a unit. The unit is molarity. So here you go with the unit and the answer. All right, one last example. The pH is 10. What is the hydroxide ion concentration? We're going to have to use 2 different formulas for this one. All right, because they're giving us the pH. So since we're trying to get to the hydroxide ion, what I would do first is find the pOH. So the first formula I'm going to use is pOH equals negative log of the OH. Sorry, y'all, that's not the first formula. Let me back up just a little bit. The first formula I'm going to use is pH plus the pOH equals 14. That's what I need to use first. So, since I know the pH, I'm going to plug that in here. So, 10 plus the pOH equals 14. So, we subtract. The pOH is equal to 14 minus 10, and we're going to least decimal places, which is to the whole number. So the pOH is equal to 4. Now that we have the pOH, I can find the hydroxide ion concentration because I have a formula that relates both of these to one another. So what you would use next then is pOH equals negative log of the OH. So now we're kind of at a similar situation that we had on the last problem. So we know the pOH, we're going to plug it in here. So I'm going to say 4 equals negative log of X, or in And so once you do that, you're going to remember to divide both sides by -1. That makes that negative and this positive. And then you're going to take the antilog again. And that's going to give you OH is equal to 1 times 10 to the -4 molar. Now, some of you may have thought of using the other combinational formulas for this, and you can. So if you by chance had a thought to use pH equals -log of H first, that would let you find the hydrogen ion concentration. So I'll go ahead and do it the second way. This is the second way to do it. You plug in the 10, they gave you the pH, plug in your 10 equals -log of H plus. So make that negative, make that positive. You're dividing both sides by -1. And then that's going to give you the, when you take the antilog of that, you isolate your hydrogen ion, and you get hydrogen ion is equal to 1 times 10 to the -10th molar. Now, this is not what they were looking for, but it gives us hydrogen ion. So now that we know that, and we're trying to find